Hello students, welcome to my channel. Me, Provish Sarkar. Welcome to my channel Math Magic. Today we will discuss about application of derivatives. The chapter application of derivatives. In this chapter, the first one or first exercise is rate measure. Okay. So let's start. So first of all, what is rate measure? dy by dx represent the rate measure of y with respect to x. Okay. Now there are three remarks. Listen number one. If y increases as s increases, then dy dx is positive. I repeat, if y increases as x increases, then dy by dx is positive. And if y decreases as x increases, then dy dx is negative. Now, number two, second one, marginal cost, or in short MC. So what is marginal cost? Marginal cost is the instantaneous rate of change of total cost with respect to the number of item produced at an instant. Okay. Now next one, third one, that is marginal revenue, in short MR. Okay. So what is marginal revenue? Marginal revenue is the instantaneous rate of change of total revenue with respect to the number of items sold and at instant. Okay, I repeat, the marginal revenue is the instantaneous rate of change of total revenue with respect to the number of items sold at an instant. Okay, now come to the examples. Okay, now first one, example number one, see carefully. Example number one, listen carefully. The question is, find the rate of change. Find the rate of change of the area of a circle with respect to its radius r when r equal to 3 centimeter. That is given. Okay, I repeat the question. Listen carefully. Find the rate of change of the area of a circle with respect to its radius when r equal to 3 centimeter. Okay. Now see, what is the area of a circle? We take A equal to, A means area. So all of you know what is the area of a circle, that is pi r square. Okay. So pi r square is the area of a circle. Now required to find the rate of change of area. Okay, when r equal to 3 centimeter. Clear? Now see, do the derivative. That means dA divided by dr. Okay, with respect to r, that is given on the question. So dA divided by r, that is pi into 2r. Okay, pi into 2r. Now put the value pi into 2 into r, that is 3 centimeter. So 6 pi is the answer. Okay. Now see, therefore area, rate of change of area with respect to radius, that is answer is 6 pi. Okay, that is unit is centimeter square per centimeter. Okay. Now see, example number 2. This is example number 1. Now see example number 2. See carefully, example number 2. Listen the question first. The side of an equilateral triangle. Okay, the side of an equilateral triangle is increasing at the rate of 2 centimeter per second square. 2 centimeter per second square. Side of an equilateral triangle. All of you know what is equilateral triangle? All the sides of that triangle are equal. That is called equilateral triangle. Okay. Now the sides of an equilateral triangle. The side of an equilateral triangle is increasing at the rate of 2 centimeter per second. At what rate? Its area increasing when the side of a triangle is 20 centimeter. Okay, side of a triangle is 20 centimeter. That is given. Okay, now what of you see, we take capital A as area. Okay, so area of an equilateral triangle, that is root over 3 divided by 4 into a square. A means side, each side of an equilateral triangle. Okay, at first we take each side of an equilateral triangle is small a. Okay, so area equal to root over 3 by 4 into a square. Okay, now required to find the side of an equilateral triangle as increasing at the rate of 2 centimeter per second square. At what rate increasing its area? Okay, at what rate increasing its area? So what rate? That means differentiate with respect to t. Differentiate both sides with respect to t. So we get dA divided by dt is equal to root over 3 by 4. That is constant and remains same. Root over 3 by 4 into a square means 2a into dA divided by dt. Okay. Now see dA by dt, area increasing rate, dA by dt, that is required to find. Now put the value root over 3 by 4 into 2 into a means 20 centimeter, that is given on the question, and rate of change the area, that is also given, that is 2. Okay, and the unit is centimeter square per second. Okay, now calculate. Here is 2 cancel, 2 to the 4, 4 cancel. So final answer is 20 root over 3 centimeter square per second. Clear everyone? Okay, so rate of change of area of an equilateral triangle is 20 root over 3 centimeter square per second. Okay, now see question number 3. Okay, see carefully question number 3. Okay, see question number 3. Listen the question first. Question number 3. A balloon which always remains spherical, okay, spherical shape, is being inflated by pumping in 900 centimeter cube of gas per second. That means push an air, the volume of air per second into the balloon, that is 900 centimeter cube. Okay, now the question is find the rate at which the radius of the balloon increasing. Okay, radius of the balloon increasing, that means required to find dr by dt. Okay, and there is data is given when its radius is 15, r equal to 15 centimeter, that is given. Okay, now all of you know in a spherical balloon is a spherical shape. So what is the volume of a sphere? See carefully, that is question number 3. Volume of a sphere, v equal to all of you know volume of a sphere, that is 4 by 3 pi r cube, that is the volume of a sphere, 4 by 3 pi r cube. Okay, v is 4 by 3 pi r cube. Now see, required to find the rate of change of its volume. Okay, see, we differentiate both sides with respect to t, or that means respect to time. So dv divided by dt equal to 4 by 3 pi, that means 4 by 3 pi, both are constant, so this is remain same. Now r cube, differentiate of r cube, that is 3r square into dr divided by dt. Okay, dr by dt. Now the question is, after derivative we get this line. Okay, now the question is required to find the rate at which radius of the balloon increasing, that means required to find dr by dt. Okay, now dv by dt, that is given 900 centimeter cube per second, that is given. So 900 centimeter per cube given, 900 centimeter cube per second, that is given. Okay, air is pumping into the balloon per second, 900 centimeter cube volume of air pushing. Okay, now 900 equal to 4 by 3 pi into 3 r square, r means 15, so 15 whole square into dr divided by dt. Okay, now required to find dr by dt. So dr divided by dt equal to 900 into 3 by 4 into 1 by pi. Okay, 1 by pi into 1 by 3 into 15 square, that is 225. Okay, now see, after calculation, see carefully, 1 by pi. So let's calculate. 3 cancel. Okay, 4, this one is 4 to the 8, again 4 to the 8, 4 5 the 20, 225. Now see 225, there is also 225, both are cancelled. So remaining is 1 by pi. That means rate of change of the radius of the balloon is 1 by pi. The unit is centimeter per second. Okay, see carefully. Okay, now come to the next one, question number 4. Okay, see. Now question number 4. Listen the question first. Question number 4. Listen the question first. This is also an important question. The volume of a cube is increasing at a constant rate. The volume of a cube increasing at a constant rate. prove that increase in its surface area varies inversely as the length of an edge of a cube. Okay, so first of all of you know, must know what is cube. A cube is length, breadth and height, all the sides are equal, that is called cube. Okay, now there is volume of a cube increasing at a constant rate. So now all of you know, if each side we take a centimeter, suppose, okay, or a unit, not centimeter, a unit. Okay, each side of a cube is a, so volume equal to v equal to, therefore volume equal to a cube. Now differentiate both sides with respect to t, so we get dv divided by dt equal to 3a square into dA divided by dt. Okay, I repeat, v equal to a cube, volume of a cube, v equal to a cube, each side of the cube equal to a, so dv by dt equal to 3a square into dA by dt. Okay, now dv by dt, that is constant given on the question, volume increasing rate is constant, so instead of dv by dt we write capital K. Okay, now 3a square come to the LHS, so we get 1 by 3a square equal to dA divided by dt. Okay, so dA by dt we get K divided by dA by dt we get K divided by 3a square. Okay, now surface area. So what is the surface area of a cube? What is the surface area? That is 6a square. So we take surface area capital S equal to 6a square. Okay, again we differentiate both sides with respect to t, we get ds divided by dt equal to 6 into 2a into dA divided by dt. All of you, hope all of you are clear. Now see, dA by dt, the value is already we get, that is k divided by 3a square, just put it. So ds by dt, ds divided by dt equal to 6 to the 12a into k divided by 3a square. Okay, now see, 3 4 the 12, so we get 4ak, 4a, 1a, only 1a remaining, so we get 4k divided by 4k divided by a, 4k divided by a. Okay, so we can write 4k divided by a, so we can write therefore ds divided by dt equal to 4k into 1 by a. Okay, so 4k is constant, so ds divided by dt varies 1 by a. Okay, proved. Okay, now see, required to prove the surface area, its surface area varies inversely as the length of an edge of a cube. So ds by dt varies 1 by a. Proved. Clear everyone? Okay, come to the next one. Question number 5. Listen the question first. Okay, hope all of you understood very well. So question number 5. Listen the question first. The question number 5 is, a ladder 5 meter long is leaning against a wall. First of all, draw the figure. A ladder 5 meter long leaning against a wall. Okay, that is ladder 5 meter long, that is 5 meter long leaning against a wall. Okay, the bottom of the ladder is pulled along the ground away from the wall at the rate of 2 meter per second. Away from the wall, the rate is 2 meter per second. Okay, now how fast is its height of the wall decreasing when the foot of the ladder is 4 meter? How fast is height of the ladder is decreasing when the foot of the ladder is 4 meter away from the wall? Foot of the ladder is 4 meter away from the wall. Okay, I repeat the question. Listen carefully. A ladder 5 meter long is leaning against a wall. The bottom of the ladder is pulled along the ground away from the wall at the rate of 2 meter per second. How fast its height of the wall decreasing when the foot of the ladder is 4 meter away from the wall? Now see, we take this distance equal to x, this distance equal to y. So this is this is Pythagoras theorem. This is a right angle triangle form. Okay, so according to Pythagoras theorem, we can write x square plus y square equal to 5 square, x square plus y square equal to 5 square, or x square plus y square equal to 25. Okay, we take this distance, that means foot of the ladder, distance of the foot of the ladder from the wall equal to x meter, and height of the ladder from the ground is y meter. So this is 5 meter. So according to Pythagoras theorem, we can write x square plus y square equal to 5 square. So we get this equation. Now differentiate both sides with respect to t. So we get 2x dx by dt plus 2y dy by dt equal to 0, because derivative of any constant term that is equal to 0. So required to find dy by dt. Okay, dy by dt. Now see 2x, 2 into x, that is 4 meter, that is given. Okay, dx divided by dt plus 2y dy by dt equal to 0. Now required to find y. When x equal to 4, this distance equal to 4, that is given on the question. How to find y? See, y equal to root over of 25 minus 4 square. So 25 minus 16, that is 9 equal to 3. Okay, we take positive root over 9, that is plus minus 3. We take positive sign because the length or distance is always positive. So y equal to 3. Now put the value of y here. So we get 4 to the 8 into dx by dt plus 2 into y, that is 3, into dy divided by dt equal to 0. Now dx by dt, that is 2 meter per second, that is also given. Just put it value. 8 into 2 plus 2 3 is 6, dy divided by dt equal to 0. So dy divided by dt equal to minus 16 divided by 6. Okay, dy by dt equal to minus 16 divided by 6. We get minus 8 divided by 3. So dy by dt, that means the height of the ladder decreasing at the rate of minus 8 by 3 meter per second. Okay, and minus sign indicates that when x is decreases and when y is decreases, x is increases. I telling at first in my video, I telling already at first, when y decreases, x increases, then dy dx is negative. Okay, so that is why negative sign is arrived. Okay, see carefully. Now come to the next one. This is question number 6. This is a very important sum from all the boards. Okay, all the board exam. This sum is question number 5 is very important. Now another important sum, question number 6. Listen carefully. Listen carefully. The question is, a man of height 2 meter walks at a uniform speed of 5 km per hour away from a lamppost which is 6 meter high. Find the rate of which the length of his shadow increases. Okay, first of all, see the drawing. Here is the lamppost. Okay, here is the man. Here is the man. Here is the lamppost. See carefully. Okay, now give the name of the figure, that is L, M, N. L, M, N. Here is S. Okay. Now see, and here is PM. PM is the height of the man. LN is the height of the lamppost. Okay. Now see, I repeat the question. A man of height 2 meter, that means PM height of the man, that is 2 meter. Okay, height of the lamppost, that is LN equal to 6 meter, that is given. 6 meter. Okay, height of the lamppost, that is 6 meter is given. Okay, now the question is, a man of height 2 meter walks at uniform speed of 5 km per hour. Uniform speed, that is also given, 5 km per hour. Okay, 5 km per hour away from the lamppost which is 6 meter high. Height of the lamppost is 6 meter. Height of the man 2 meter. Okay, the man walks away from the lamppost at the rate of 5 km per hour. Okay. Now the question is required to know that, or question is the find the height of the rate of which the length of the shadow increases. Length of the shadow increases. Okay. Let NL be the height of the lamppost, PM be the height of the man. Okay. Now here we form an similarity using the formula of similarity. These two triangles. See. PSM and LSM, two triangles are similar. I repeat, PSM and LSM, two triangles are similar triangle. Okay. Now see, we can write using similar triangle. We can write SM divided by SN. SM divided by SN. SM divided by SN is equal to PM divided by LN. Okay. Now put the value PM divided by LN. Okay. Now we take Mn equal to X. We take Mn equal to X and Sm equal to Y. We take Mn equal to X and Sm equal to Y. Okay. Now see. So we can write Y divided by Sm. Sm, that is Y. Y divided by Sn, that is X plus Y. X plus Y equal to PM, that is 2, Ln, that is 6. Okay. Now do the cross multiplication. Okay, do the cross multiplication. So 3y, here is 1 by 3, 1 divided by 3. So 3y equal to X plus Y. Okay, or 3y equal to X plus Y, or y equal to, or 2y equal to X, or y equal to 1 by 2x. Okay. Now differentiate both sides with respect to t. Differentiate both sides with respect to t. So we get dy divided by dt equal to half into dx divided by dt. Okay. So dx by dt, that is given. That is 5 km per hour, that is given. That means the man move away from the lamppost. The speed of the man away from the lamppost, that is 5 km per hour. This is dx by dt, that is given. So half into 5, answer unit is kilometer per hour. So 5 by 2 kilometer per hour. Okay. So see carefully, dy by dt, that means shadow increasing rate. The shadow increasing rate dy by dt is equal to 5 by 2 kilometer per hour. Clear? Hope all of you understood. Next, come to the another example. Question number 7. Okay, see carefully. Now see question number 7. Listen the question first. Listen the question first. The amount of pollution content added in air in a city due to X diesel vehicles is given by Px equal to look at the equation. Px equal to 0.005 x cube plus 0.002 x square, 0.002 x square, 0.005 0.005 x cube, 0.02 x square, 0.02 x square plus 30x. Okay. Okay. Now listen. The amount of pollution content added in air in a city due to X diesel vehicle is given by Px equal to 0.005 x cube plus 0.02 x square plus 30x. Find the marginal increase in pollution content when 3 diesel vehicles are added. Okay, 3 diesel vehicles, that means x equal to 3. X equal to 3. 3 diesel vehicle is added. Okay, 3 diesel vehicle is added. When 3 diesel vehicle is added, and write which value is indicated in this equation. Okay, I repeat the question. Listen carefully. The amount of pollution content added in the air in a city due to X diesel vehicle is given by Px equal to, given this equation, find the marginal increase in pollution content when 3 diesel vehicles are added and write which value is indicated in this equation. Okay. Now see, px equal to this one. So all of you know marginal increase. All of you know marginal increase. If we derivative this equation, if we derivative this equation, that means dy, find dy by dx, we get marginal increase. Okay, so marginal increase equal to d dx of px equal to, after derivative we get, uh, 0.015 x square plus 0.04 x plus 30. After differentiation, we get marginal revenue, that is dx of px, that is this one. Okay. Now, when x equal to 3, that is given when x equal to 3. So dy by dx of px equal to 0.015 into 3 whole square plus 0.04 into 3 plus 30. Okay. Now marginal, when x equal to 3, marginal increase, okay, marginal increase equal to this one. So after calculation we get 30.255. After calculation we get 30.255. Okay, that is the marginal increase of pollutant when X diesel vehicle, that means 3 diesel vehicle is include. Okay, now the value indicated is the increase in pollution content air in the city. That means the value indicated that increases the pollution content added in the air in that city. Okay, got it? Hope all of you understood very well. Thank you, students.